Just say hello. Oh, hey, welcome to the night class. We're going to do lesson 6.3 today. Exponential functions. All right. Everybody knows what an exponent is, yes? Yes? Okay. Exponential function would be something that has an exponent that's a variable. So, trying to get where I can write for a second. I should have already had this done.
Oh my God. Okay, that's wonderful.
All right. So, if it's y equals 3 to the x, x is the what? Exponent. So this is an exponential equation. Okay? The only requirement is for your variable to be a what? An exponent. Okay? If there's a variable in the exponent, it's an exponential equation. Okay? Linear is just y equals mx plus b. Quadratic has an exponent of 2. These are all going to be exponential equations. Okay? So, our first example here says, does each table represent a linear or an exponential function? So I'm going to use this example to kind of teach how you figure this out. All right? So notice the x's. They're just going up by 1, right? Okay? How are the 2's change, or the y's changing? Excuse me. They're adding 2 every time, right? Plus 2, plus 2, plus 2. Everybody follow that? That is linear. When you're adding a number to get the next number every time. Okay? What's happening here? They're multiplying by 2, times 2, times 2, times 2. That makes it exponential. That makes sense? Easy enough? So if you're adding or subtracting to get the next number, it's linear. If you're multiplying or what? Or dividing, it's exponential. Okay? Everybody clear so far? Easy enough? All right. Let's try one for you. Let's see if we were right here.
Do we need to be a typer?
Yes, sir. See, they said the same thing I did. Yay. All right. Next one. Look at A. Give you about 2 seconds. No, I'll give you a little more than 2 seconds. And let's see which one is linear and which one is exponential, or I guess they could both be linear, they could both be exponential, but I don't think they are. All right. Kyler, what you think about A? They're adding 2 again every time, right? Okay. Are they going up by the same amount on the top? Yes. That should always be the same. Always be the case. No matter if it's exponential or linear, okay? If it's going up, last time it's going up by 1 every time. This time it's going up by 2 every time, okay? So that should always be the same no matter what. So this is linear. Oops. This is linear. And again, why? Because they're adding to get the next y, okay? What about this one? Exponential. Very good. That's a very ugly exponential, but I was writing sideways. I apologize. Everybody good with those? Easy enough? Not too bad?
Not too shabby.
Not too shabby?
Better than my handwriting.
Next. That's the tutorial. I don't think we need a tutorial. I think we're good. Example 2. More that's pretty simple, okay? Is this an exponential function? Everybody should say yes. Why?
There's an exponent right out.
Because the exponent is the variable. Everybody understand how to tell when one is an exponential function or not? The exponent will be an x or a y or an a or a b, okay? It'll be a variable. So, evaluate, that's a fancy word for just do what?
Solve it.
How? But what do you do to solve it? You do it with like plugs.
Yeah. Plug it.
You plug it in. Okay. You plug in
negative
right there.
2 times 5 to the power of 3.
Very good. Everybody good there? And from there, you can basically just put it in your calculator. Okay. But if you didn't have a calculator, let's say, am I going to multiply those first and then do the power?
I would do the exponent first.
Y'all remember old PEMDAS? Okay. Please excuse my dear Aunt Sally.
Oh, yeah.
You got to do your parentheses first, then your exponents, okay? Then you multiply, divide, add, subtract, okay? So you got to do this part first, and then multiply that by
I always
-2.
get it confused.
Okay.
This is like parentheses. I think like multiplying -2 times 5 because that's like
When you
parentheses.
see parentheses, you need to think, okay, what's inside the parentheses is what you do first. Very good, okay? So, but like I said, if you have your handy-dandy calculator, you just put it in. As long as you put it in just like that, it should give you the right answer. What'd you get?
Negative. Y equals negative 250.
-250. Woo! Yeah. -250. That's going down. How about this? Same thing, right? To the -2 power. Put that in your calculator. And tell me what are we going to get? How much? -3? 12? I got a 12. I need a second. Do I have a second? It's like a board meeting.
God bless you, my brother.
Anybody else get 12? Y'all grab your little yellow calculators and punch the buttons and see what you get. Okay? You got a 12 too, Ethan? Show me. I know.
I got 12.
This ain't my first go round.
I got a blank.
Let me see. Yeah, because you just typed 1, 2.
Well, I mean, he did get 12 in the calculator.
You technically
Type that in and see if you get
I
12.
did get 12.
You too. You too. What's your number?
He said yellow calculator. Pretty yellow, man.
I got that picture still.
Oh, really?
Sure do.
How do you put that 2 up for?
You hit,
The little arrow right there.
and this is why I want you doing it.
This piece of junk.
I got 12.
Got 12.
I know.
Beautiful. I guess it's 12 then.
I reckon so.
All right. Any questions so far? Pretty easy. Y'all are acting like it is. I hope it is. Let's see here. Let's move on. Example 3.
I'll keep it. I want it. I'll take it.
All right. Here we go. I make that. Ooh, I can't make it bigger. Look at that. Okay. It says to graph f of x equals 4 times 2 to the x power. Compare the graph to the graph of the parent function. Describe the domain and range of f. Okay. So I'm going to try to draw me a graph here.
Oh, we have graphs.
This is why you have graph paper.
Yeah, we have graphs. You know, you can like go to like the little thing, like the little picture thing, and like make a graph chart, right?
I
Like a
know.
whiteboard. Okay, you want to know something? I'm not good with names. I'm just good at what I'm learning right now. Be quiet.
All right. Now,
Don't need to.
let's see what this graph's going to look like. We're going to make an XY table. Now, there's a bunch of ways. Who gets to pick the X's?
Now you don't.
We do.
You do.
Yeah,
Okay?
we do.
Now, there are certain X's that are easier to plug in than others. This is the way I like to do it. Okay? This is just a Coach Knight way of plugging in. Okay? This family is the exponential function family. Okay? And I always like to make the exponent 0, whatever it may be. So on this one, how can I make the exponent 0? I just plug in what? 0, okay? But I want you to understand, I'm going to make another one here. Say g of x equals 4 times 2 to the x plus 4 exponent. What would I plug in first if that was my problem?
A 4.
Not 4, but what? You're close. I'm wanting to make the exponent, what I say?
0.
0. So what would make the exponent 0?
Negative 4.
-4. That would be my first point that I plug in. Okay, that's just always my starting point. And here's why. We learned it not yesterday, but the day before. Anything to the 0 power is what? Not 0. 1. So 2 to the 0 power would be 1, and we have 4 times 1 is 4. So my first y is 0. Oh, excuse me. My first y is 4. All right, plugged in 0, I got 4. Everybody with me? Then you go right and left of 0. Okay, so I'm going to start out going right. So what's 1 to the right? 1, 2. And I just do a couple. Okay, don't do a lot because exponential functions get really big really fast. Okay, so if I plugged in 1 for x, 2 to the 1 power is 2, and times 4 would be 8. So I'm already at 8, and I just plugged in 1. Okay, if I plugged in 2, 2 squared is 4. 4 times 4 is, I'm already getting too big to graph. So I'm going to stop there. Okay, is there any rule that says every point you put on your table, you have to put the point on the graph? No. Okay, so if you pick a point and it's 16, like I'm not going to use that point because it's just too high. Okay, my graph would be too big. Is that making sense? Okay. All right. Now, if I go to the left, I'm going to pick -1, -2, and so on. Okay, so here's where it gets a little interesting. Another thing, you got to remember your properties. If I plug in -1, okay, what actually happens to that 2? Do I want it to have a negative exponent? No, I want it to be positive, right? So what can I do to make the exponent positive? Do y'all remember?
Add a positive.
No.
No, we add another negative. Negative is negative.
No. If it's at the top, where can I put it?
On the bottom.
On the bottom. So that will become 1/2 to the 1 power, which is just 1/2. And what's 1/2 of 4? 2. What if I did -2? Then I move it to the bottom, and that's 1/2 squared. Well, again, that's 1 over what? 4. So 4 times 1/4 is 1. Okay? Is everybody seeing how that works? If I did -3.
I forgot negative x is the number is going to go down.
It's going to make it go to the bottom. So -3. Now I'm going to have 2 to the 3rd would be 1/8. So what is 4 times 1/8?
1 to the
That'd be 4/8. What is 4/8? You said it, I thought. 1/2. Okay? And as you can see, what are we multiplying by every time? We started, see, we did them kind of out of order. So if I started at 0 and got 4, and then I got 8, and then I got 16, what am I multiplying by? 2. But then I started going the opposite direction. So 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. Is that making sense? Okay. And then you just graph them. All right. So 0 to 4, 1, 2, 3, 4. 1, 8. That's 5. We'll say 6, 7, 8 would be about up here somewhere. All right. I'm just guesstimating. Y'all have the graph paper, so it should be easier for you. 2, 16. Like I said, I'm going to leave it on my table, but I'm not actually going to graph it. Okay. -1, 2 would be right there. -3. Oops, I'm sorry. -2, 1 is right there. -3 1/2 would be right there. And can you see what's happening here? It's just kind of looks like a what? It kind of looks like a ramp to me. You ever watch American Ninja Warrior? You know that little warp wall that they got to jump up. And that's what it kind of looks like. Okay. Now, this line, will it ever cross our x-axis right here? It won't. Can somebody tell me why?
There's no negative.
Because before it to get to this line right here, what does y have to be? Not a negative.
No.
What's every y on this line is what? 0. That's 1 0, 2 0, 3 0, right? Okay. Is it possible 4 times 2 to the x? Is it possible to make that equal to 0?
No.
It's not. It's impossible.
Rosie Wall, please report to the front office.
Exponents don't make things 0. They make things really big, or they make things what? Really small, but they don't make them 0. Okay? Now, how small can it get? It can get as small as your little imagination can imagine. Okay? But does it ever get to 0? No, it does not. Okay? It just keeps getting closer and closer and closer and closer to 0, but it doesn't ever get there. Okay? I compare it like if Leighton stood up and I walked halfway to him, and then he walked halfway to me, and then I walked halfway to him, and then he walked halfway to me. Would we ever, theoretically, get to each other? No, because as soon as we did, somebody didn't go halfway. Somebody went the whole way. Does that make sense? Okay, so that's kind of what you're doing here. You keep getting closer and closer and closer to 0, but you don't ever go the whole way. All right, and the being this negative, if you notice, my negatives made my numbers what? Smaller, right? Okay, that's when I started getting 2 and 1 and 1/2. So if I'm going to make it really big, -100. Okay, I don't even know if it'll give you an answer if you put that in your calculator. Let's see if it does.
Nope.
It doesn't. It actually does. It's 3.15. We'll say 6 times 10, and it says e to what power? -30. So what that means is the actual number is 0.30 of them, right? And I have one number here. So 29 zeros.
And the 3.
All the way, blah, 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 blah. 0, 3, 1, 6. Yes. Yes. What is that number basically?
A lot.
0. But does it ever actually get to 0? No, it just keeps adding more zeros in between the numbers. Is that making sense? Everybody cool with that? Okay. All of your graphs should mimic this little ramp here if they are exponential. Okay. Now, will it always go up? Nope. Sometimes it might go up. It might go down. Sometimes it might be going up this way or down this way. Okay. It can go all different ways. All right. Everybody good?
It's never across the y-axis, right?
It can, though, if I did this. Okay. 4 times 2 to the x-axis. If I put behind that -2. Well, do you remember your transformations? Okay. You know, your translations or slides.
Oh, yes.
Okay. It could translate left or right or up or down. You got when you multiply by something that stretches or shrinks. You remember talking about those? There's a section in every chapter. Okay. You got reflections. When there's a negative involved, it might reflect up and down or reflect left and right. Okay. So this, when it's -2, that means this entire graph just shifts down how far? 2. So this point right here would go down to, this point right here would go down to, this point right here would go down to, and now rather than approach 0, what would my graph approach? What's this line right here? -2. That's always going to tell you what you need to approach. You follow me? Here, on the original, and you can't see it because I got too much stuff written. Okay? On the original, it doesn't have anything after this. Okay? But it's like saying +0. It's approaching 0 because nothing's there. But whatever that number is, that's what you're approaching every time. That makes sense? Okay. All right. What is my domain and range? It says describe the domain and range. So we're looking at the blue, and let me change to blue. All right. Yes, sir.
Can you turn there?
I can. Domain. What can the domain be? Domain are the x's, right? How far can it go left? How far can it go right? So domain is all real numbers. Okay? How far will it go up? How far will it go down? It only goes to 0. So the range, y can only be greater than
Dennis, you have a checkout?
0. Can I put equal to?
No.
No, because remember, does it ever get to it?
No.
Doesn't ever get to it. So it has to just be greater than y, or greater than 0. Okay? Everybody good? All right, I'm going to pause it. Same process here. Make my table. Oh, wow.
And I get home to like.
Make my table, or my graph, excuse me.
Wasn't even supposed to come to school today, but you know, coach not maybe.
I did?
Yeah.
Cool.
I ain't got no camera.
You got a whip. You got a
All right.
watch
What am I going to start at? What's my first x on this? Is that right? 0. It's going to be 0 again. All right. What would I get for my y if I plugged in 0 there? Not 1, but
4.
camera. 4.
2.
Hold up.
Negative 1.
-1. Okay. And then we start going right and left. All right. So 1, 2, 3. That's enough. Y'all plug those in your calculator real quick. So negative, parentheses, 1/2 to the 1 power. What would that be? Negative 1/2. All right. What if we did the 2 power? And to make it quick, look, you can do. Yeah, you already know the trick, don't you?
1/4.
Negative 1/4
Yeah, I was about to say that.
Negative 1/8.
and negative 1/8.
I'm hippie.
And we keep getting smaller and smaller and smaller, right?
Negative 1/16.
This is negative 0.5. This is negative 0.25. And this is negative 0. What is 1/8 as a decimal?
64.
You're an
Yeah,
idiot.
just put 1 divided by 8.
45.
You're really
Okay, 1 divided by 8.
If it's 45, I get the back.
0.125. So again, we are getting closer and closer to what? Well, 0, but will we ever get there?
Yeah.
Not going to get there on this one. All right, let's go the other direction. -1, -2, -3. Let's see what we get when you plug in -1.
-2.
Negative what?
2.
2? All right, what about when you plug in -2?
-4.
-4. -8. I'm getting too big. Okay, so we graph.
You don't like saying things.
0, -1. 1, -1/2 would be about right there. 1, -1/4 would be about right there. I'm just guesstimating. 3, -0.2125 would be, I just keep getting closer and closer to what? The 0, right?
My graph doesn't do that.
-1, -2, -2, -4. And I'm not going to worry about doing the last one because I don't have room. So there's my graph. Okay.
My graph knows what you do.
What's my domain one more time? Is it any different? No. It's still all real numbers. Y'all listen.
And then
All right. What about my range?
y something 0.
Y something 0.
Yeah, something.
What's the something?
I don't know.
Well, how far down does it go?
It's cold here now.
A lot.
It goes where? What's this arrow mean?
Damn, son.
It's going forever, but it goes up. Does it go up to forever?
No.
It only goes up almost to what?
Y-intercept.
Which is,
Zero.
that's the x-intercept, by the way. Okay? 0. All right? So that's where the 0 is coming from. So it's either more than 0 or less than 0. It would be less than. Is it equal?
No.
Can't be equal.
No.
Okay? Can't be equal. Any questions? Everybody good?
Was that the answer you're looking for?
It
Nope,
was
I'm tired.
less
I said
than.
it probably 10 times.
Okay,
You
now
didn't say it loud enough.
Shush.
I didn't hear you.
How many times did I say it?
Okay, you need to just shush.
All right. Moving on.
0.125.
What is that equal to?
Zero.
Here.
Example 5.
Example 5.
Ooh,
Yay.
okay. I'm going to graph it on the board one more time. This one's different. I like different.
12
All right. X, Y. What's going to be my first X this time? Not -3,
+3.
+3.
I got it right.
And again, the reason I want it to be 3 is because I want my exponent to start out being what? 0. And 3 minus 3 is 0. Okay? Why do I want it like that? Because it makes the math easy. This 2 cancels because it's just 2 to the 0, which is 1. So you have 4 plus 2. What is 4 plus 2? 6. That's my first point. Okay? Does everybody follow how I'm doing that?
Yes, sir.
All right. What's 1 to the right of 3?
1 to the right.
4. And then 1 to the right of that would be 5. 6. That's enough. Let's go the other direction. What's right before 3? 2 and 1. And if you want to throw in 0, go for it. Okay? Remember, if the number's too big or too small, you ain't got to use it. Okay? So if I plugged in 4, what does that give you? 10? That's 4 to the 1, or 2 to the 1 power is 2. Times 4 is 8. Plus 2 is 10. I'm already kind of big. Okay? I might not use any of these problems. If I plug in 5,
18.
you get 18. 18. 5, that would be 2 squared is 4. 4 times 4 is 16. Plus 2 is 18. Very good. What if I plug in 2?
4.
4? All right, I'm going to trust you. And what about 1? 2.5?
Oh, when I put 0 in.
Okay.
Someone's the worst thing you can do.
Okay.
You.
Shush. 3.
3? 3.
I didn't say.
The lady says 3. And what about 0?
2.5.
2.5?
Not a good one.
All right. Do one more for me, just for kicks. Do -1.
400 degrees.
What do you get?
Yeah.
Trying to show you something.
-3.
34.
34? That's not. Oh, you put, I think you did -3 instead of -3. Yeah.
There we go.
You did -3.
It's -3, right?
2.2, 2.25? Is that right? Okay. So, watch my points here, okay? We got 3, 6. 1, 2, 3. Up to 6 would be right about there. 4, 10. I'm not going to worry about graphing this one or this one. 2, 4 would be right here. 1, 3. 0, 2.5. -1, 2.25. What am I approaching that I'm not going to cross? Not 0 this time. 2. There's an understood line right here that I'm not crossing. Everybody understand that? Okay? This is the point that you're always going to be approaching. You're never going to go past or above it, depending on where you're coming from. Okay? Everybody got that? So when you graph yours, make sure you don't mess up and go past whatever line you're not supposed to go past. Okay? So it's going to look like that, or pretty close to it. Okay?
That's a beautiful rate, Coach.
Thank you. Can do like a skate. I could do a ollie. 360.
I think you do a little bit more.
A 540 McTwist.
Yeah.
Make flurry.
Did you say an ollie 360?
Yeah.
I mean an ollie 540.
Oreo McFlurry.
Let's see if example 3 is in, or 6 is any different. I think we're going to skip
Coach,
that.
what's a kick flip?
Kid.
Kick flip.
All right, we'll do this one. Last one.
What is it then? What do you have to do?
Kick.
Shut your mouth.
All right, last one. The graph represents a bacterial population Y after X days. How about bacteria? I mean, this is relevant right now, right? Write an exponential function that represents the population. Find the population after 12 hours and after 5 days. Gracious. All right. Find the population after 12 hours and after 5 days.
132
All right, well, let's see here.
hours.
132 hours?
Either right.
I have no
12 times 10 is 120 then plus.
That sound solid.
132.
where are you getting 10,
Yeah, you ain't got that.
There's
bad.
12. 24 hours
right?
is in 5 is in 1 day.
Right.
So you divide 40. You can't, instead of multiplying,
It sound like
if you do
that, right?
12s instead of 24s, you can just multiply 2 by 5 and then divide
I see. Okay, I get what you're saying.
24.
All right, so here's what you need to do. Every one of these has a starting point, okay? All right, so this starting point was at day 0. We had how many?
0.
3, okay? So every time you're going to have y equals a times b to some power, okay? Your a is how much you have initially, all right? It's how much you have initially. So on day 0, we have a left because 0 would take out the b, okay? So what's our a? What would our a be? If 0, we got 0, 3. What's our a got to be? Not everybody all at once.
What is it? 400, Coach.
3. Right here. That's your initial amount. Okay? B
Equals.
is what you're multiplying by to get the next one. So let's look at our numbers here. We go from 0, 3 to 1 what?
12.
What happened? What did we multiply by? 4. Then we went from 112 to 248. What did we multiply by? 4. Then we went from 48 to 192. What did they multiply by? 4 again. So B is what? 4. Can't write. B is 4. All right? That's all you need. So for part A, my equation is y equals, what was A? 3 times 4 to what power?
No.
It's a ladder.
X.
X to the x power. That is my exponential function that represents that population. Everybody with me?
Yeah.
Okay. Part B. And again, before we move on, I got A from whatever that initial amount is. I got B from figuring out what are they multiplying by to get the next numbers. Everybody got me?
Yeah, sure.
Find the population after 12 hours. So what am I going to plug in for X to represent 12 hours?
Hang on, I'll get you there.
No, you're putting stuff in your calculator and you don't need to right now. What you think?
A lot.
What are these down here? Days. 12 hours is how much of a day? Half. So what do I need to plug in for X? Half. Because I want to know 12 hours. 12 hours is half a day. I want to know half a day. Okay? So y equals 3 times 4 to the 1/2 power. Now grab your calculators and tell me what we get.
I'm big old.
Shouldn't be a big old.
I'm just kidding. I got it. Hang on, give me a moment.
6.
Yeah, that's what I got.
That's exactly what I got.
Yellow.
6.
What? Is that not what I got?
What do we plug in to figure out how much there's going to be after 5 days? Or what do we plug in to figure out 5 days? What do I let x be?
5.
5. What do you get?
3,072. Yeah.
So, half a day, we're only at 6, but by day 5, we got 3,072.
Very relevant.
That's very, yes, very quick. All right? Any questions? We're going to do one more of those just because I like it. It's fun.
12,388 for the next answer.
You think so?
We gonna make a bet?
No.
You have no money.
Tyler says he knows.
All right, let's see how much we listened here.
49,100.
Hey. All right, for part A, same process, writing the exponential function. Okay? Every time it's y equals ab to the x power. So a is how much I have initially, right? Okay? So Lacey, how much do I have initially here? 3. It's 3 again, isn't it? Okay, is it going to be 3 every time? No, it's just, that's a coincidence, okay? So y equals 3, and then what is b? B is what are we multiplying by to get the next number? So we went from 3 to 9, from 9 to 27, from 27 to 81. What do they multiply by every time? 3. So they're both 3 this time, okay? Can I reduce that to 9 to the x power? Say no.
No.
Yeah.
Now tell me why you can't.
Because it's making something different.
Excellent. All right. I can't multiply these because this 3 has a what with it? An exponent. And we don't know what it is. Remember, you have to do the exponents first before you can multiply. Okay? Part B.
Ow!
All right. Population after 12 hours. Again, this is silly. It's the exact same. What we're measuring in days here. So 12 hours would be how much of a day?
Half.
Half of a day. So 3 times 3 to the 1/2. And then they also want to know 6 days. 3 times 3 to the 6th. So what would those be? Little what? First one's what? A decimal? Probably. 5.19. 196, blah, blah, blah. And then what about to the 6th?
2,187.
2,187. Good gracious. All right. Hope this video helps you at home. See you next time. And as always, stay above the line.